In this video, I'll be reviewing the notes for parallel lines cut by transversals and the angle pairs that are created. So we've already learned corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. And we saw these when the lines were not necessarily parallel. But now we're going to be focused on when the lines are parallel and they have a transversal cutting through them, what specific angle relationships occur, and what do they mean specifically. So when we see corresponding angles, alternate interior angles, or alternate exterior angles when they're through a parallel line, they are all going to be congruent to one another. That's what these first three theorems are telling us. So if two parallel lines are cut by a transversal, then these three types of angles will be congruent. Now the one that is slightly different than those three are the consecutive interior angles, and remember those are the angles that are on the inside of the parallel lines but on the same side of the transversal. Those will not be congruent, but they will be supplementary to one another, so they'll add up to 180. So we're going to use this information to find the missing angles, and in some cases we need to solve for missing variables in order to evaluate what the actual angle measure will be. So we're going to try these problems by just first looking at the diagram, seeing what information is given to us, so what is that going to let us figure out. In the left column here, we're going to put the angle measure when we figure it out, and then in this right side column, we're going to put the reason. So what theorem did you use in order to figure this out? And it might be the theorems that we had above, or it could be ones that we've learned already, like linear pair and vertical angle. So go ahead and try to pause this and press play when you're ready to check your work. Okay, so for this diagram, I've labeled what was given. We knew that angle 1 was 100 degrees and angle 5 was 75 degrees. So I filled those in on the labels. We can see that line C and line D are parallel. We know that they're parallel because of these markings on the lines. So when you see two lines and they have the markings on them of the arrows like this, it tells us that they're parallel to one another. So we could say that C, or line C, is parallel to line D, and this is kind of like the symbols that we use to say that those two lines are parallel. Since they're parallel, we can use those theorems from above to say which angles are congruent, which ones are supplementary, and so on. So in angle 2, I can see that that's a linear pair with angle 1, and I will know that angle 2's measure will be 80 degrees. In angle 3 then, I can either say it's a vertical angle to angle 1, so I'll know it's congruent at 100 degrees, or the other way I know that it's 100 is because 2 and 3 are a linear pair, so they need to add up to 180. And then angle 4, I know it's vertical to angle 2, so it'll be congruent, or I know it's a linear pair with angle 1, and so it needs to add up to 180, and so that makes that 80 degrees. So each of those are now able to be filled in on our diagram. And we're going to use those to help us keep going. So now to figure out these angles down here, 9, 10, 11, and 12, we're going to need those to figure out, we're going to use the top ones to figure out the bottom ones. So for angle 9, we can see that angle 9 is an alternate interior angle with angle 3. Because they are going through the transversals going through C and D, we know that these two must be congruent. So I'll know that angle 9 will be 100 degrees because it is an alternate interior angle with angle 3. I also know it corresponds to angle 1, and it's also a consecutive interior angle with angle 4. So it adds up to 180. So for any three of those reasons, we can say that the measure of angle 9 will be 100. Measure of angle 10, well, angle 10 is an alternate interior angle to angle 4, so they must be congruent. We also know angle 10 is corresponding with angle 2, so those have to be congruent. And angle 10 is a consecutive interior angle with angle 3, so they must be supplementary and add up to 180. So that means the measure of angle 10 is 80 degrees. For angle 11 then, we have lots of reasons. We can say that it is corresponding with angle 3. It is an alternate exterior angle with angle 1. It's a linear pair with angle 10, and so for that reason, 100 degrees would be our measure for angle 11. For angle 12 then, it is vertical to angle 10, so we'll know it's congruent. We also know it is an alternate exterior angle with angle 2. It is now a linear pair with angle 11 and angle 9. So for any of those reasons, we know that angle 12 was 80 degrees. To move on to our next set, we were given that angle 5 is 75 degrees. So using that knowledge, we can figure out that angle 6 would have to be supplementary to it because they are linear pairs. And so we would take 180 minus 75 to get a difference of 105 degrees for the measure of angle 6. From there, we can say that angle 7 will either be a linear pair with angle 6 or it's vertical to angle 5. And for either reason, that tells us that it's 75 degrees. Then in measure of angle 8, that is a vertical angle with angle 6, and so it will need to be congruent. We also know it's a linear pair to angle 5 and angle 7 now, so we'll say that the measure of that will be 105. And finally, down below, when we have 13, 14, 15, and 16, we need to now focus on this set of angles and this set of angles to figure them out, because this is the transversal B cutting through C and D. We already figured out 1, 2, 3, 4, 9, 10, 11, and 12. They had a different transversal, and so they were related. These pink angles will not be related to each other because they are a separate transversal through the same set of parallel lines. So knowing that, I'm going to use that knowledge. Measure of angle 13. Well, angle 13 is a corresponding angle with angle 5. It is an alternate interior angle with angle 7. And angle 13 is a consecutive interior angle with angle 8. So for all of those reasons, we can say that angle 13 will be 75 degrees. Measure of angle 14 then, we can say is an alternate interior angle with angle 8. It is a linear pair with angle 13. It is corresponding to angle 6. And for any of those reasons, we can say that that one will be 105 degrees. In the measure of angle 15, there are a couple reasons why that may then work. Angle 15 is corresponding with angle 7. It is an alternate exterior angle to angle 5, and it is a linear pair with angle 14. So for all of those reasons, it will be 75. And measure of angle 16 then, it's vertical with angle 14. It is a linear pair with angle 15 and angle 13. It's corresponding to angle 8, and it's an alternate exterior angle with angle 6. So again, there's many different reasons why all of these were able to be figured out. If you were asked to prove these, you would only need to give one of these reasons, but you need to make sure that you're using the reason using that given information. So now we're going to do a couple more examples using these same theorems, but this time there's going to be some expressions where we need to solve for the missing variable. So if you think you're ready to just try this, go ahead and pause the video, but I am going to do the first one as an example together. So in this first example, we can see that this angle is vertical to this angle. So because those are vertical angles, we can first set these two expressions equal to each other because we know that vertical angles are congruent. So I can say that 2x plus 4 should equal x plus 32. I don't know how many degrees either of these angles are, but finding x is going to help us figure that out. So I'm going to subtract x from each side. I get x plus 4 equals 32. And when we subtract 4 from each side, we figure out that x is 28. We're going to use this to evaluate each of these angles. And I'm going to say 2 times 28 plus 4 gets me 56 plus 4, which is 60 degrees. So right away, that means this should equal 60 degrees. We're going to double check by evaluating for when x is 28. And we see that, yes, this is 60 degrees. So now I know that these are 60-degree angles because they were vertical. So now that I've figured that part out, I'm going to use some of our new theorems to figure out the other missing angle. I can see that I have angle 8y minus 4, and something that I can figure out in this diagram is that this will be vertical to this angle, which means that that angle, even though we can't see it, is going to be the same measurement. And so I'm just going to erase this so we can see this a little bit better. So this angle was 60 degrees. This one will be 8y minus 4 because it is vertical to the highlighted green one. And because those ones are going to be vertical, we can call it the same amount. Then this angle, the yellow angle, x plus 32, which we found was 60 degrees, will be a consecutive interior angle with this green angle. So that means that the yellow angle plus the green angle should equal 180 because they are consecutive interior and they must be supplementary. So that means I can take x plus 32, add it to the 8y minus 4, and set it equal to 180. Then I can just solve using what I know. We already figured out that 28 plus 32 was that 60-degree angle. And we're going to add that to our green angle and then solve for y. Because I've already solved for x, this lets me solve this equation for just one variable and not having to deal with two. So I'm going to move this problem over here. I'm going to combine my like terms. So when I do that, I get 56 plus 8y equals 180. I'm going to subtract 56 from each side, and that gets us 8y equals 124. We divide by 8, and y is equal to 15 and a half. And it looks a little weird, but we're going to go plug it in and make sure that this makes sense. So it was 8 times y, which is now 15 and a half, minus 4. Well, 8 times 15 and a half gets us 124, and if we subtract 4 from that, that should equal 120. If that's 120 degrees, then this one should be 120 degrees. These were consecutive interior angles. They add up to 180, so 60 plus 120, that looks good. Because this is vertical to this one, then we can ultimately say that this is 120 degrees. And so that lets us finish solving that equation, and we get our missing variables for x and y. So now that we've done that one together, go ahead and pause the video and try these other two for yourself and press play when you're ready to review. Okay, so in the first example here, I started by setting the 4x minus 16 equal to 3x plus 14. I did this for two reasons. First of all, they are equal because they are alternate exterior angles. And then second, I started with this because x and x, they had the same variable. I can't do anything with the fact that this is a linear pair yet because this is an x, this is a y. I wouldn't be able to solve for both variables in one equation there. So I'm going to first solve for x and then go back and solve for y. So when I solved for x here, I figured out that x equals 30, and I plugged that into both of my green expressions, and I figured out that those two green angles were 104 degrees. Well, then that helps me see that if I take that 4x minus 16 plus 3y plus 2, if I add them together, they should be supplementary, or 180, because they are a linear pair there. And so I can plug in my x that I already knew and get an equation to solve for y. I end up getting that y is 74 thirds. Just leave it in that fraction, because when I go ahead and plug that in to my 3y plus 2, that yellow angle that we were solving for, when I multiply 3 times 74 thirds, then the denominator cancels with that 3, and we get 74 plus 2 for a total of 76. When I go back and double check, 104 plus 76 does equal 180, and they ended up being supplementary as they should have been. In the second example, again, I kind of had to decide which one am I going to do first. Well, I could see that both these green angles that I highlighted are both using the variable y. They are a linear pair, so I started by adding them together to equal 180. We solve for y, and we end up with y equals 45. When I evaluate each of the green angles for 45, I see that I get 105 and 75. Then I need to look at, well, this angle, this 105 degree one that was 2y plus 15, is equal to the 5x plus 8 because they are alternate exterior angles. So they need to be congruent so I can set their angles equal to each other. Well, I know that the 2y plus 15 is already 105, so I set it equal to 105, solve for y, and I get y equals 97 fifths. When I go ahead and evaluate that in the yellow angle, 5 times x, which is 97 fifths, plus 8 gets me that angle of 105, which is congruent to its alternate exterior as it should have been.